If you had to guess, which flying animal would you say is faster, a hummingbird or a honeybee? The animal we're looking at today has some of the tiniest wings in nature, yet it has the tendency to flee faster and smoother than them. If we look more closely, their wings are even smaller than the body. Yep, it's the honeybee. They can fly that fast because they flap their wings at the most unreal speed, something even birds can't do. It's 200 times a second to be precise. But how do their tiny little bodies generate that much energy? Welcome to another episode. Today, we're going to learn about the insect that can flap its wings 200 times a second. Are there any others that can do the same or are faster? Keep watching to find out. Bees are mostly found around flowers collecting nectar. They tend to shift from one flower to another with such speed and rhythm that it catches everyone's attention. Bees, despite having a large body, can flap their wings 200 times within a second. But how can they fly so well with such tiny wings? When speed is synchronized with the tiny size of the bee, the air viably feels thicker to a bee's wing. So when the wings beat, they make complex examples of vortices around the wing. It intensifies the measure of power it makes when it travels through the air. The rapid wing development and beautifully streamlined craftiness explain why these bees with such little wings can fly so well. And if you really think about how they can beat their wings so fast, there is really only one logical answer. In contrast to birds and bats, honeybees have no muscles that append straight to the wings. The primary wing development is driven by two enormous sets of muscles in the chest. These muscles are called dorsoventral muscles and the dorsal longitudinal muscle. Now, dorsoventral muscles run from the top to the lower part of the chest, and the dorsal longitudinal muscle runs from the front to the rear of the chest. When the dorsoventral muscles contract, the entire body gets crushed from top to bottom, which makes the wings fold upwards. And on the reverse, when the dorsal longitudinal muscle gets squeezed, the body gets crushed front to back, so the wings fold downwards. An important component of these muscles is that they show something called stretch activation. It implies that the muscles become dynamic soon after they are extended. The dorsoventral muscle and dorsal longitudinal muscle are antagonistic muscles, which means they act in inverse ways. Basically, when one contracts, the other is extended. It's like the movement to the rear arm muscles and biceps muscles in your arm. So, the way that the dorsoventral muscles and dorsolongitudinal muscle kind of work against each other, and the stretch initiation, implies that when one contracts and moves the wings, the other is extended and becomes dynamic, moving the wings the other way. That extends the other muscles again, so they become dynamic and contract, and the cycle continues on. This movement happens unintentionally. It's like blinking or breathing. The brain doesn't need to send messages through nerves to the muscles. If anything, that would be slower. This way, the muscles can act autonomously, which is why the honeybees can beat their wings so quickly. If we consider the abilities of other flying creatures, they surprisingly pale in comparison to the humble honeybee. Birds and bats have a similar body engineering to us. To flap their wings, the chest muscles pull the wings forward, while the shoulder muscles pull the wings in reverse. These muscles are adversarial. They don't show stretch enactment. So this solid action has to be directed by the sensory system, which, as we just said, is much slower. Bird and bat wings likewise require more power to move, plus they're heavier and produce more drag. So you can see how it might be tough for other animals to match up. The lack of stretch actuation and the strength needed for development explains why these creatures can't beat their wings close to as quickly as bees do. Dragonflies can accomplish something like numerous bugs and birds can't. Dragonflies can fly forward, backward, straight up, or in a crisscross style. They can fly faster when moving forward in a straight direction, and their eccentric flying patterns can confuse and sometimes frighten their prey, even when they're flying at a lower speed. Dragonflies can also float by utilizing their wings to balance in the air. Dragonfly wings beat so quickly you can barely see them moving. How does that compare to a bee? Well, a dragonfly can thrash its wings 300 times a second. Butterflies are pretty surprising in this regard too. Researchers have found that butterflies can fly with the most elevated speed of 30 miles each hour, and surprisingly quick. At a sluggish pace, they can fly 5 miles an hour. So, for the most part, butterflies can fly up to 20 to 30 miles each day without any problem. But that also depends on the breeze and temperature, since both can ruin their flying speed. Monarch butterflies are most commonly compared to hawks because they both need thermal air to support their flying and cross huge water bodies to arrive at their future destination. However, monarch butterflies use terrains to fly, whereas hawks use thermal air. Surface breezes can seriously influence the movement journey of monarch butterflies, so they lean toward tailwinds coming from the north. These airs can push them towards the south. Still, solid breezes coming from the south can block their excursion and their capacity to fly higher. In more troubling climates, monarch butterflies fly into covered areas to save their energy and time. Now, when it comes to wing speed, the hummingbird is the first to come to mind. They're quick little birds, always zipping about everywhere, so surely they must flap their wings pretty quickly. Well, the truth is, they flap their wings only 80 times a second. That's much less than a bee and even lesser than a dragonfly. I think we can all agree, though, that hummingbirds are significantly heavier than bees and flies, so it's not completely odd. But what's interesting is that hummingbirds don't actually flap their wings. They rotate their wings in the shape of the number 8, which is even more remarkable. But the fastest of all, even faster than the bee, is an insect you might not be the biggest fan of: the mosquito. I know, they're annoying little things, but they actually flap their wings up to 720 times per second. That ominous buzzing sound you hear when a mosquito is around you is actually the sound of its wings. They do fly slower than bees, though, so in the end, the big body and tiny wings of bees win over the large wings of birds, butterflies, bats, and dragonflies. So there it is. Do you know any other animals that can flap their wings just as fast, if not faster? Which flying creature won your heart? Tell us in the comments below. Make sure you hit that subscribe button and ring the bell so you never miss a video from us. See you in the next one.